Bem-vindo and welcome back to our class. Today we're going to talk about participating in academic activities. Specifically, how you might present your work to other people in an academic setting and how to understand when other people are presenting their work. For this, I've gone to a science fair located at the University of Colorado. There I interviewed a young man who had done some research on nanoparticles. We're going to listen to that interview and know that he speaks rather quickly and there is some background noise and it is very technical. So this video might be a little more difficult to understand than other ones we've had in the past. Nevertheless, I think you'll do just fine. I'm going to help you by stopping the video intermittently and asking you some questions. Okay, you ready? Let's go. Okay, the first question is, in just a few words, what problem is he trying to address? Watch the video and see if you can answer that. If you're not sure, go ahead and rewind it and play again and see if you can figure it out.
So hi, my name is Hari and this is my project this year. And the problem I was trying to address is based on nanoparticle exposure.
How'd you do? That was kind of hard, but what he's trying to address is simply nanoparticle exposure. Now the next question, I want you to tell me, why are nanoparticles put in milk?
And nanoparticles are being increasingly used in our everyday lives. You might not know it, but you and I have probably been exposed to nanoparticles at one time or another. They are put in your milk to give them their color. They are put in your car tires. They are put in your printer toners. They are put in your batteries. They're put in food preservation devices. They're put basically in everything.
Right, so nanoparticles are put in milk to give it its color. In the next clip, I want you to watch for the 3 attributes of nanoparticles that make them really easy to work with. One is that they're small. One is that they're easy to reproduce. Can you give me the third one?
So nanoparticles are so increasingly used because of their very unique properties. They have very high surface area to volume ratios, they are very small, and they are easily engineered and reproduced. And this makes them very good candidates in biomedical fields, industrial applications, consumer goods, and many more places.
Good, so the third reason was actually the first one that he gave, and it's that they have a high surface to volume ratio. In this next clip, I want you to start looking for what he talks about the primary pathway of exposure. So how do people get exposed to nanoparticles?
However, with nanoparticles, everything isn't good. There's also risk of exposure. Nanoparticles have potential to do devastating impacts on the body. They have potential to do real harm. Therefore, they need to be screened for toxicity because they're being increasingly used in our lives. And the primary pathway of nanoparticle exposure is inhalation. If I threw some nanoparticles in the air right now, they would probably disperse immediately and become completely invisible to the eye. So basically, I could go around inhaling these nanoparticles without knowing it, and they may actually have adverse impacts on my body.
If you said inhalation, you are right. So by inhaling nanoparticles. In this next clip, he reiterates or restates or refines what his research is about. Can you listen for it and tell me what that is?
So for this reason, I wanted to understand how nanoparticles influence your lungs. How do they interact with your lung tissue? Because the inhalation pathway is really going to be the highest use.
Did you get that he's looking for how nanoparticles interact with lung tissue? If so, nice job. In this next clip, I'm looking for a type of cell. So what type of cell makes up 99% of lung tissue? Listen for it.
And of the lungs, 99% of the cells in your lungs are epithelial cells. And so knowing how nanoparticles influence epithelial cells is extremely important to evaluating their toxicity.
If you said epithelial cells, you are right. Now in the next clip, he's going to talk about 2 types of cell junctions. Can you listen and tell me what those 2 types of cell junctions are?
Now, to evaluate how nanoparticles influence the epithelium, I evaluated how they influence cellular junctions. Now, cell junctions are, as the name suggests, places where two cells basically meet. And the focus of this project were two types of cell junctions, tight junctions and gap junctions. And these play critical roles in the epithelium. Tight junctions maintain epithelial barrier function.
Did you get the two types of cell junctions to be tight junctions and gap junctions? If so, great job. Next question is, what do epithelial cells or the epithelium do?
For example, the epithelium is supposed to be a barrier. It's supposed to protect your body from foreign substances. If your epithelium is leaky, then it's gonna let a lot of bad stuff get into your body. And for this reason, dysfunction of the tight junctions can lead to acute respiratory distress syndrome, sepsis, both of which have over 400,000 US deaths a year. Gap junctions are responsible for cell-to-cell communication within the epithelium. Dysfunctions of your gap junctions can also lead to many adverse effects, such as inflammation and decreased wound healing.
This next question is a little easier. It's a yes or no. So the question is, have nanoparticles been screened for cellular toxicity in the past? Has this type of study been done before?
So this is really what I wanted to address, because nanoparticles have never been screened for toxicity based on their cellular junctions. So this is really novel research.
The answer is no. This is new or novel research. The researcher will mention two methods that he used in his research. One is mRNA expression, and I'd like you to listen for the other one. What is it?
So what I basically found using mRNA expression, using a dye transfer assay, the biggest result of this was that nanoparticles do alter the function of tight and gap junctions with potentially adverse effects.
Did you say dye transfer assay? He said that really fast, so good job if you got it. Okay, next question is, how many therapeutics did he test? And by the way, what is a therapeutic? If you don't know, look that up.
I also tested two therapeutic interventions that I can use to mitigate nanoparticle-induced alterations of gap junctions. Those therapeutics were indomethacin and a p38 inhibitor.
So a therapeutic is a treatment, and he tested two of those. Your next question is, listen for, did the therapeutics have any effect? So did they work?
These therapeutics were able to repair the damage caused by nanoparticles to the gap junctions.
Yes, they did. So they were able to repair some of the damage done by nanoparticles in gap junctions. The researcher in this next clip, he mentions a third outcome of his study. Can you listen for it and tell me what it is?
And lastly, I established a mechanism of toxicity by which nanoparticles influence gap junctions. And the reason this is very important is because we need to know this mechanism of toxicity will help doctors with targeted drug delivery. They can analyze specific factors along the pathway of toxicity and mitigate these specific factors in order to solve the entire problem. So these things are very, very important.
The researcher indicated that he established the mechanism of toxicity to gap junctions. In this next clip, the researcher talks about what future research should address, so the implications of his study on future research. There are two items that he thinks future studies should address. What are those two items?
And the implications of this study, we now have a new evaluation of toxicity. This procedure can be implemented in many occupational settings, and this can be very important to determine nanoparticle toxicity. And future studies should address nanoparticle-induced effects on maybe other types of cell junctions, because tight and gap junctions aren't the only ones. And they may also want to address nanoparticle effects on the epithelium in other settings.
He's suggesting that future research should focus on nanoparticles and their effect in other types of cell junctions, or on the epithelial cells in other contexts. Wow, that was a really tough video. How'd you do on it? If it was hard for you, don't worry. That was a lot of quick talking and a lot of technical language. But if you want to watch it again and try again, I bet it will be easier the second time. This has been one example of a student talking about the academic work that he's doing And I want you to notice a couple of things. He talks about the background of the study, why he was doing it, kind of the point of it, like what he was trying to determine. He talked a little bit about the methods, and then also the outcomes of the studies, the results. Lastly, he discussed the implications for future research. Those are some good main points to hit if you are going to be talking about your research, and they're good main points to listen for when other people are talking about theirs. I hope that was really helpful for you, and I look forward to seeing you next time. Have a great day. Ciao.